Today we are going to be talking about nuclear chemistry. Nuclear chemistry is the study of changes that occur within the nuclei of atoms. Generally, this is how nuclides are represented. X is the element symbol. A is the mass number, which is also known as the nucleon number. This is the same thing as the number of protons and the number of neutrons combined. It is called the nucleon number. Nucleon number because all of the protons and neutrons reside in the nucleus. Z is the atomic number. It is the same thing as the number of protons. Here's an example of the representation for uranium. Uranium's atomic number is 92. Uranium has 92 protons and 146 neutrons, so its mass number is 238. Uranium can also be described or written as 238 uranium or uranium 238. Electrostatic force is the force that causes opposite electrical charges to attract each other and like charges to repel each other. The positively charged protons in the nucleus of an atom have an electrostatic force pushing them apart. The other force within the nucleus, called the strong force, holds the protons and neutrons together. Each neutron in the nucleus of an atom is attracted to other neutrons and to protons by the strong force. They act as nuclear glue to hold the particles together. Adding neutrons to a nucleus increases the attractive forces holding the particles of the nucleus together without increasing the amount of repulsion between those particles. Although a nucleus consists of only two protons is unstable, a helium nucleus that consists of two protons and two neutrons is very stable. The increased stability is reflected in the significant amount of energy released when two protons and two neutrons combine to form a helium nucleus. There are 264 stable nuclides found in nature. This graph shows the neutron-to-proton ratio of these stable nuclides. These nuclides fall within the band of stability. A nuclide that is outside this band of stability will be unstable until it undergoes one or more nuclear reactions that take it into the band of stability. These unstable atoms are called radioactive nuclides, and the changes they undergo to reach stability are called radioactive decay. To reach the band of stability, there are three types of emissions. They are alpha emissions, beta emissions, and gamma emissions. In alpha emission, the atom releases two protons and two neutrons in the form of a helium nucleus. This is also called an alpha particle. Uranium gives off an alpha particle and is left with a stable version of thorium. In beta emission, a neutron becomes a proton and an electron. The proton stays in the nucleus, and the electron, which is called a beta particle in this context, is ejected from the atom. Iodine converts a neutron to a proton and ejects an electron. Positron emission is similar to beta emission, but a proton becomes a neutron and an antimatter electron or anti-electron. Another way to become stable is through electron capture. In this, the electron combines with the proton to form a neutron. In this case, iodine moves towards stability through electron capture. Because radioactive decay leads to more stable products, it always releases energy. Some of this energy is released in the form of kinetic energy, but often some of it is given off as the form of radiant energy called gamma rays. Gamma rays can be given off in the form of photons during beta emission. The end.